Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. In the lecture series of Fundamentals of Mechanical Engineering and Mechatronics, which is the first year BTech subject, today I am covering the lecture related to Unit 5 and the topic is pressure measurement. So previously I have covered various lectures related to measurement and why measurement is necessary, why we are going to measure the different physical quantities, why the measurement is essential. So in that lecture series, today I am covering pressure measurement. So before moving towards the pressure measurement, I would like to cover what basically the pressure and why it is essential to measure the pressure. So I hope that this term is very well known to us. The pressure, that is the external force or the thrust per unit area. This is what the pressure is. And pressure can be used for the purpose of measuring the variables such as the flow and the level. And it also plays an important role of the boiling point of the liquid. Yes, boiling point of any liquid is the function of pressure. If the external pressure, if the surrounding pressure is very high, then obviously the boiling point will be high for that particular liquid. But if the pressure is less, so then the boiling point will be less in that particular condition for the same liquid. So pressure plays important role. So it is necessary when we are dealing with the liquids, so how much pressure is there in the surrounding, otherwise that liquid may get evaporated. Okay. Fluid exerts pressure on the containing vessel equally in all directions. This is what basically the Pascal's law. But wherever the fluid is contained, wherever the liquid is contained, it exerts thrust on all the sides of the container vessel in which it is contained. So it is also necessary to measure pressure. So pressure in today's life, we are dealing with the pipes, we are dealing with the flow of the liquid through the pipes from one country to another country, from one city to another city. In the plants also, we use the supply of liquid through the pipes. We are containing the various liquid. So it is essential to measure the pressure at every instant, at every time. So it is well said by someone, in any given plant, the number of pressure gauges used is probably larger than any other instruments put together. Because for the purpose of control, for the purpose of safety, for the purpose of operation, it is necessary to monitor the pressure at every instant, at every place in a plant. So that's why it is important to measure the pressure. Now, how to go for the measurement of pressure? Now the question comes, how do we go for the measurement of pressure? There can be methods where we can purely use the mechanical system. A pure mechanical system can be used, because if I come to the point, I will be explaining in the later portion of this, the complete system can be a mechanical system. But sometimes mechanical systems are having certain inertia. Mechanical system requires larger velocity ratio. Mechanical systems, so sometimes it is not possible to get the desired output with the help of mechanical method. So what do? We convert that mechanical system, or we correlate that mechanical quantity which is changing with physical quantity change into a electrical. So that method is known as electrical method. Now I will be explaining this particular thing which I discussed just now. Suppose pressure is applied on any container, any substance, any body. Suppose I am standing here. So because of my standing, there is a pressure on the floor. So that floor, if it is a pressure sensing element, in which some change is observed due to the applied pressure. So that element will be what? That element is known as pressure sensing element. And that can be what? That pressure sensing element can be a plate, can be a shell, can be a tube. Okay, so that can be. I will be covering in the lecture later on what these are. Okay, so that pressure sensing element can be anything. And what will happen in this pressure sensing element? Definitely because of the pressure, because of the sense of the pressure, it will create some displacement. As I told, I am standing here because of the pressure. There is a certain displacement in the floor if we can sense that. If this displacement is transduced means converted into some other quantity, which is easily readable, which is easily diagnosable. So because of the pressure, displacement occurs. If this displacement is transduced in some other form of the signal, which can be any electric signal, and that can be very commonly used voltage or current. As we discuss about the piezoelectric substances. In the piezoelectric substances, because of the change in pressure, it generates the electric current. But not necessary if the piezoelectric substance is not there, but there is a change in the pressure. Because of that, the displacement is there, and if this displacement can be transduced in some electrical quantity such as voltage or current, that can be easily readable. And we must, as a researcher, as a scientist, as an engineer, we must establish a relation between the pressure and the voltage, so that voltage or current can be the indicator of change in pressure. So that's what I have written here also in the form of, so pressure के through displacement, then through displacement it is transduced in some electrical signal, और वो electric signal क्या हो सकता है? That electric signal can be a voltage or current. So now I am coming to the point, what are the different ways, what are the different concepts for measuring the pressure? There are certain concepts related to the pressure measurement. We can measure the pressure with the help of manometer. Okay, manometer, I will be discussing this. Two red indicators are indicating that these two I am going to discuss in detail. Second one, that is the elastic pressure transducer. So the meaning of elastic is clear. I will be covering this. Pressure measurement by measuring the vacuum. That can be the another concept for measuring the pressure. Electric pressure transducer. As I told, piezoelectric transducer can be one of that. Pressure measurement by balancing forces produced on a known area by a measured force. So by measuring the force also we can measure the pressure. So now I am covering these two, first two, manometer method and elastic pressure method. Manometer is basically nothing. Here we are observing that a U-tube manometer is there. The shape of this manometer is in U shape. So that's why it is known as U-tube manometer. It is filled with a manometric fluid. The fluid which is filled in the manometer. This also has certain characteristics. This manometric fluid, it should not be corrosive. It should not be cohesive with the glass, so that if it is cohesive, then its flow will not be fair. Okay, so one of the limb of this U-tube manometer is connected with the container in which the pressure has to be measured. Okay, and other limb is open to the atmosphere. Very good. So if the pressure in the container is high as compared to the pressure of the surrounding, ambient pressure, atmospheric pressure, then what will happen to this manometric fluid? Obviously, this manometric fluid will rise in the side of manometer which is open to atmosphere, Basically, it is nothing. It is basically the balancing of weight. It is the balancing of weight. So on that basis, I can write the equation that the pressure here, pressure in this container is equal to the P naught, which is the ambient pressure, plus rho GH. Rho GH is what? It is nothing. The change in pressure with the height, rho GH, where rho is the density of the manometric fluid, G, that is the known to us, acceleration due to gravity, and H, that is the difference in the height of the column. So that is the, so, and vice versa is also true. If the ambient pressure is greater than the pressure in the container, then kahan par ye manometric fluid rise karega? It will be rising in the limb which is connected to the container. So the equation will be opposite one. So that is what basically the manometer. Through manometer, we can measure the pressure by balancing the weight of a fluid column between the two pressures of interest. And here two pressures of interest are the pressure which has to be measured in the container, another that is the ambient pressure. Another way of measuring the pressure is the use of elastic transducer. The meaning of elastic is as it is, as we know. Elastic means if something recovers its actual shape and size after removal of the force. Here we are applying the pressure, here we are measuring the pressure. So because of the increase in pressure, there observe a change in the behavior of that element, and after removing the pressure, it again comes to its actual shape. It means the transducer or the sensing element which we are using in this particular method are elastic in nature, are flexible in nature. So it is written also, it uses a flexible element as a sensor. As pressure changes, the flexible element moved, and this motion is used to rotate a pointer that I will be discussing. And these commonly used, as per our syllabus also, commonly used elastic transducer for measuring the pressure are Warden tube, bellows, and diaphragm. So these Warden, bellows, diaphragm, these are the main types of sensing element which are normally used for pressure measurement through elastic transducer method. Okay, and all except diaphragms provide a fairly large displacement, and this displacement we are going to convert in what? As in the previous slide also. First, the pressure, there is a change in pressure that will be sensed. That will be sensed with the help of what? That will be sensed with the help of pressure sensing element, which are Warden, which can be Warden tube, which can be bellows, which can be diaphragm. And there will be a displacement in that. There will be a displacement. So that is what written over here. So sensing element for sensing the pressure, Warden tube, diaphragm, and this. And all except the diaphragm. Diaphragm ke alawa, either it is a Warden tube or it is a bellows. A fairly large displacement, and this displacement will be converted into a electrical signal with the help of electrical sensor. So that is what the pressure measurement by elastic transducer. Now here we can see this is what the Warden tube, this is what the diaphragm, and this is what the bellows. So I am covering the Warden tube basically. So pressure measurement by the Warden tube pressure gauge. Warden tube pressure gauge. What basically it is? Warden tube, it means it is a part of the elastic transducer. So it is elastic. What are the different types of Warden tube pressure gauge? One is, that is the C type. Because of its shape, we can see, we can observe that it is a C type Warden tube. I am discussing the working also. I am discussing. Okay. This is what the helical type. This is what helical type. Okay, helical type. And this is what the spiral type. All these are the elastic transducer for the measurement of the pressure. Okay, depending on the range, depending on the accuracy, we are using different Warden tubes in different cases. So this is what the Warden tube. Now what is happening here? I am discussing the C-type Warden tube. Okay, this is the pressure connection. So from here, we can say the pressurized fluid is entering. Because of the entry of the pressurized fluid, what is observed? This is the flexible, this is the elastic tube. This is the tube, Warden tube, which is of C shape and it is elastic in nature. So because of the change in pressure, here I am assuming the pressure is increasing. So because of the increase in pressure, what will happen to this? Obviously, this C will open. This C will open as the fluid, the high pressure fluid is flowing through it. So because of that pressure, this C is opening. And there is a mechanism arrangement, there is a link, there is a sector of the pinion, there is a gear arrangement. So because of this, this pointer will move. This pointer will deviate. Angular displacement will be there. By making number of experiments, I can establish a relation between the pressure which is exerted here through the pressure connection and how much deviation the pointer is taking place. So that can be useful for designing a C-type Warden tube. But here we can observe, this is completely a mechanical method. So here what we can observe, obviously we can measure the pressure, but there are certain limitations, there is a certain inertia of this link, there is a certain velocity ratio relation or the issue with the movement of the pointer. So it is very difficult to sense small changes in the pressure. So what can be the solution for this type of problem? The solution is that we can convert this purely mechanical system into a electrical integration system, electrically integrated system. The core concept will remain same. The core concept remains same means what? Because of the application of pressure, there will be a deflection, there will be a displacement. Now, how do I measure that displacement? Either with the help of the movement of the pointer or some other arrangement. So, I am having an integration between the mechanical and electrical system. Okay. So, the same thing. Here again we are observing what? A C Warden tube pressure gauge. Okay. So, the pressure is exerted from here. Because of the pressure, obviously this tip of C will expand, will open. Because of this displacement of the free end of the C-type Warden tube, what will happen to this cord? This cord will move and it will cause the movement of this core. What is basically here? This is completely known as the LVDT, linear variable differential transducer. It means linearly यदि कोई चीज move कर रही है, because of this, what transduction, what electrical quantity can be changed. So for measuring the linear motions को measure करने के लिए, displacements को measure करने के लिए, we use LVDT type of system. So what basically we are observing? This is the primary winding, this is the secondary winding. So we are observing this is some type of transformer type of arrangement. That is the core. So because of the displacement of this core, and this displacement is occurring, why? This displacement is occurring because of the movement of this cord. Why this cord is moving? This cord is moving because this tip of the C is getting displaced. Why this is getting displaced? Because of the change in pressure. So pressure is through the cord is converted into, the change in pressure is converted into the linear movement of this core. Or as this core is moving, what will happen to this? Obviously, the output voltage here associated with the secondary binding will change. This is easy to measure. No gear, no link, no kinematics, no mechanism is there. It is easy to measure the voltage. Changing with what? Changing with pressure. So this is what the electromechanical pressure measurement with the help of mechanical plus electrical system. This is elastic in nature because as soon as the pressure is reaching to its actual value, it again regain its actual shape. So in this way, it is easy to measure. And nowadays, the pressure measurement is done maximum with the help of these type of system. So I hope the discussion related to the pressure measurement, which is useful from exam point of view also, is clear to you. So thank you for watching the video. Thank you very much.